So in this video, I'm going to talk about convergence of sequences. I'm just going to, that's all we're going to do is just determine if the following sequences converge. So I'm going to show you 4 different examples. So really, like with sequences, honestly, like you can just basically take the limits of these and kind of like see what happens, I guess. So let's start with this first example. So I've got 3 to the n over n cubed. So the whole thing with sequences is we want to see what happens as n goes to infinity, and that's really what's going to tell us if this is going to converge or not. So as I take the limit here, I notice I've got infinity over infinity, which is, that means that we can use L'Hopital's rule. Ta-da! So let's see. Let's go ahead and let's take the derivative of the top and the bottom. So hopefully you didn't forget your derivative of 3 to the n. And then in the bottom, this will be 3n squared. So now if I take the limit, this is still going to be infinity over infinity. So I can go ahead and take the limit, or take the derivative of the top and bottom again. So now this is going to be natural log of 3 squared. And then in the bottom, this will be 6n. I've still got infinity over infinity. All right, so let's see. Is this the last time that I have to do this? Let's see if I take the derivative. Yep, so this is the last time I have to do this. So now I have infinity in top and just 6 in the bottom. So now I know that this is going to equal infinity. So since this equals infinity, that means that this sequence diverges. Okay, so let's take a look at this next one. So a sub n equals 2n plus 2 factorial over 2n minus 1 factorial. So factorials are like, they're kind of fun to think about. So if I think about like just kind of blowing this out for a moment, so the top will be 2n plus 2, and then I multiply 2n plus 1, and then I multiply 2n, and then I'll multiply 2n minus 1, and this is just going to keep going down the line, right, until we get 2 times 4 times 3 times 2 times 1. That's what a factorial is. So I start here, and then I just multiply by one lower number until I've gone through the whole thing. So I bring this up because then at some point, right, I get this 2n minus 1 over 2n minus 1 factorial. Cool. So those cancel out, right? And this is important to notice because this will really change how we take the limit. So this is just equivalent to multiplying these terms. So now when I take the limit as n goes to infinity of these terms, so I've got 2n plus 2, 2n plus 1, and 2n. Well, obviously this is just going to go to infinity now, right? So this means that this sequence diverges. Okay, so up next, so we have natural logs. I don't know what the deal is, but a lot of my students really hate natural logs, but it's okay. Natural logs are fine. So the first thing that goes off in my brain is that, okay, I've got a natural log minus another natural log. So I can totes my goats rewrite this, right, as n over n minus 1. Okay, and so now when I want to take the limit as n approaches infinity of this whole thing, well, I know that like I really just need to focus what's happening on the inside here. So I'm allowed to simplify the inside. I'm just going to divide everything here by n so that I just simplify the inside like this. So these are equivalent, right? But now this is helpful because this is going to go to 0. So then I'm just left with so then the limit of this will be the natural log of 1 over 1, which is the natural log of 1, which equals 0. And since we have a value here, what that means is that our sequence converges. Okay, and so last we've got the sequence, just the inverse tangent of n. So for this one, so if I take the limit as n approaches infinity, so you've got to know something about inverse tangent. But if you know something about inverse tangent, so the graph actually has an asymptote. So at some point, this just goes, like the asymptote of this graph is pi over 2. And so it is helpful to know, the basics of your different trig functions for these types of problems. Okay, so that is the end of this video. So I will catch you guys in the next one. Thanks for watching.